All right, guys, we're going to try and answer this question given the values in the table. If sufficient data are provided, complete the blank cells in the following table of properties of water. In the last column, describe the conditions of water as compressed liquid, saturated mixture, superheated vapor, or insufficient information. So what we're given here is we're given values for pressure, temperature, and specific volume. And we're asked to find the enthalpy and describe the condition. So for row A, we're given 270.28 kilopascals and a temperature of 130 degrees Celsius. Okay, so first thing we're going to do is we're given this 278.28 kilopascals. So we're going to go to the pressure table, which is A5, and we're going to look at and see if we have that here. And as you can see, we don't exactly have anything for 270.28. But if we also look, they've given us 130 degrees Celsius for temperature. So if we go back here and we look at this table A4, we can see that they give us a value that we can find that 130 here, and with it, the pressure is 270.28. So we can use this right here to find the information in the table. We're asked to find the enthalpy, and that's all we're really given. So if we look at this table here, and we look at this column right here, we can see that this is our enthalpy. And we're given saturated liquid, evaporation liquid, and saturated vapor. So if we take a look back down here at the 130 degrees, we can see that this right here is our values. So since we weren't given any other information, we can take these values and we can pick any one of these enthalpies. For the first column, note that this is going to, if you pick this number, the 546.38, that is going to be your saturated liquid. Okay, anything in between this number and this last number, which is your saturated vapor, if you pick a value in between this number, this is going to be your saturated mixture. And all of those should be correct, just depending on whether you label it correctly. So I'm going to go ahead and pick the saturated vapor, this Hg value of 2720.1. So I've got 2720.1, and that is our saturated vapor. Okay, so now moving on to row B, notice that we weren't given a pressure for this one, but we were given a temperature of 120 degrees Celsius, and we were given a specific volume of 0.2000. So the first thing we want to do is we want to find the pressure. So if we can go back to that table and see if we have the value for 120, you can see here that we are given, we do have 120 for the temperature, and our pressure is going to be this 198.67. So 198.67. Okay. So now we also need to find the enthalpy for H. And here, this one's a little bit different because we're given this specific volume. So we've got to find the exact enthalpy that's going to be for this specific volume. And in order to do that, okay, we're going to take these values for the specific volume, which is this one right here. This is our V of F, and this right here is our V of G. Okay, and we're going to take those and we're going to find the quality, which is defined as the mass fraction of the vapor phase. And to do that, we are going to do V equals V of F plus X V of FG. And in the table, we were given a V of F, but we weren't given a V of FG. But all V of FG is taking this V of G value and subtracting it from this V of F value. So we're given the V, the specific volume of 0.2000, and our V of F is 0.001060. Okay, and we're looking for X, and to find our VFG, it's taking the V of G of 0.89133 and subtracting it from V of F, which is 0.001060. Okay, and when you solve this out, you should get a quality of 0.22346. Now with this right here, we can use this to find our enthalpy by using this similar equation, and that is going to be H of F plus X of H of FG. So now we're going to go back to the table and we're going to get these values for H of F and see if we can find the values of H of FG. So back at 120, under your enthalpy column right here, you can see that we were given the H of F and we're also given the H of FG, so we won't have to subtract the H of G for this one. So we'll just take these values and plug them back into our equation. So this time we're looking for our enthalpy, which is H. Our H of F was 503.81 plus X, which is what we found up here. So 0.22346 times H of FG, which was also given in the table. That's going to be 2202.1. And when you solve this out, your enthalpy will be 995.89. Okay, so that's our answer for our enthalpy. So 995.81. I'm sorry, 89. And we're going to take this value and find out where that lies on our graph. So we're looking for the enthalpy. Where does enthalpy fall between here? As you can see here, this is our saturated liquid, and this is our saturated vapor. So as you can see, the 995.89, it's going to fall within this area right here. This is just your FG, which is the subtracting your FG from H of F. So it's going to fall between these two values right here. So this is going to be considered your saturated mixture. Okay. Now for the last one, for row C, we were given a value of 1600 kilopascals for the pressure and no temperature this time, but we were given a specific volume of 0.2499. Now, right off from this, we can see that our pressure is this really high number, a high value. So we can assume that this is probably going to be in the superheated region. So we're going to scroll down here to table A6. We got 1600 kilopascals, which is the same thing as 1.6 megapascals. And we were given a specific volume of 0.2499. So what we're doing is in this first column right here, we're looking for the specific volume of 0.2499. And as we look, we can see that it's right here. So all we really need is now to go over to our enthalpy and look to see what that value is. And here it is, it's 3693.9. So that's our value for our enthalpy. So 3693.9. And since we were looking at the superheated table, that's going to be in the superheated region. All right, guys, thanks for watching. I hope this answers your questions.